Continuing where I left off in the last video, looking at question number F right here, and we want to solve it. First thing I notice is that it's not in standard notation. We need to first subtract the 12x from both sides to get it equal to 0. So writing this in standard notation, it would start with the 9x squared, followed by the 12x, then the plus 4. Right, always an x squared, then x, then constant notation. Equals, and then when we subtract that off, so it's going to equal 0. And we're going to try to factor it. So nothing goes into all of these, so I don't have a GCF. So I'm going to look at what kind of a factoring this is. It's a trinomial, 3 terms. The coefficient is not 1, so I can either use trial and error or I can use grouping. So I'm going to go ahead and do grouping this time. So to do grouping, we start by multiplying the first and the last. 9 times 4 is 36. And we're going to try to find two numbers that go into 36. Positive 36 needs to add to a negative, so they're both going to be negative, and they need to add to a negative 12. So 36 is 9 times 4. 9 minus 4 is negative 13. It's close. Doesn't work. 36 is 6 times 6. That's a negative 12. That is what we need, so that's the right one. So let's rewrite this. 9x squared minus 6x minus 6x plus 4 equals 0. And we're going to group the first two and the last two. In the first two, you can divide them both by 3 and x. So pull 3x out. That leaves us with 3x. 6 divided by 2, or by 3 is 2, so minus 2. Minus, those have a 2 in common, so it'll be 2 as the GCF, and that'll leave us with 3x minus 2. 4 divided by negative 2 is negative 2, equals 0. Right, this isn't completely factored yet. I need to keep factoring because these are in common. I can write 3x minus 2 times 3x minus 2 equals 0. Alright, now I've got a product equal to 0, so the zero product property says that either 3x minus 2 is equal to 0 or 3x minus 2 is equal to 0. Now these are the same thing, so I really only need to solve one of them. There's only going to be one unique answer in this case. So let's add 2 to both sides. It's going to give us 3x equals 2. Divide by 3. X equals 2/3. If I solve this one, I will get exactly the same thing. I don't need to say x equals 2/3 and x equals 2/3. A single 2/3 is the same. Noting that these are the same, I only need to input one answer. There's only one answer to this one. X equals 2/3. Okay, so as I said before, most of these problems will have two answers, but I had to say most because there are some that will only have one. Okay, we may also see some that have no answers. Perhaps if I can't factor at all, I wouldn't be able to get any answers. Alright, let's look at problems G and H. G is not written in standard form. I need to do a couple of things. First, I need to distribute. So I'm going to distribute, and I'm going to get 4x squared minus 11x equals 3. Then we're going to have to subtract the 3 from both sides so we can get it equal to 0. So 4x squared minus 11x minus 3 equals 0. And it's time to factor. This is again a trinomial with coefficient not 0, similar to the last one, but I'm going to use trial and error on this one just for contrast. So I'm going to start my parentheses and figure out how I want to make that 4x squared. I can choose 1 and 4, or I can choose 2 and 2. I don't know yet what the correct answer is, so I'm going to go ahead and try 2 and 2. For the 3, 1 and 3 are my only options, but I'm not sure yet if it's 1 and 3, or if it would have been 3 first, then the 1. Okay. I do know that I'm going to have one positive sign and one negative sign. I don't know which one's supposed to be which. I'll just throw some in there and try it, knowing that I'm probably going to have to get it wrong and try again. So let's look at these. This one gives me 2 times 3 is negative 6x, plus, oops, that line went way too far. That line went all the way to the 1 times 3, which I already knew. I want the 1 times 2. I need the mixed terms for the center here. Okay, and so those add up to negative 4x, which is not what I want, so those aren't the right answers. Okay, 1 and 3 didn't work. Maybe 3 and 1 will work. So let's try that. Okay, so this is 2 times 1 is negative, sorry, I'm thinking out loud. I need to write what I say. So 2 times 1 is negative 2, and 3 times 2 is positive 6. So that just gave me a positive 4x. That didn't work. Okay, so there aren't any other ways to make a 3, which means I need to go back and get rid of the 2's that I've used to make the 4. That wasn't the right choice. Let's try 4 and 1. Okay, so 4 times 1 is 4x, negative, plus 3 times 1 is 3x, so I've got negative x. Still not what I want. I need a negative 11. So let's try the 4 and the 1 with the opposite way to make a 3. Let's try that with 1 and 3. So 4 times 3, that's negative 12x, plus 1 times 1 is 1x, is negative 11x. So finally, after 3 scratch outs, we got the right one. Okay, so let's erase some of this because we're going to need that space. Okay, so we have this factored now. We don't even need to write that 1 in front of the x. So we have this factored. It's equal to 0. So we're going to set each part equal to 0. 4x plus 1 equals 0. X minus 3 equals 0. And we'll solve each piece. Subtract the 1. That would be 4x equals negative 1. Divide by 4. So x is equal to negative 1/4, or if you add your 3 to both sides, that one would be x equals 3. So we have our two options. So as we can see, factoring is the longest part of these problems. Once I have it factored, the steps after factoring are quite quick. Okay, let's look at the last one on this page. Alright, this one's already in standard form. It's equal to 0. It's a trinomial, coefficient 1, so I'm going to use just the last number here. That number is positive, so I need two of the same, two positives. And so let's go. What goes into 4? So 2 plus 2 is 4, so that's going to work. So this will factor into x plus 2. X plus 2 equals 0. So I know that either x plus 2 equals 0 or x plus 2 equals 0. I only need to do the same thing once. So when I subtract 2 from both sides, I know that the answer on this one's going to be x equals negative 2. Next page. Alright, we're going to look at a graphical example here. The graph of y equals x squared minus 10x plus 28 has been drawn right here. I'm going to erase my rough sketch because it looks terrible. That's our graph, this parabola shape we saw in section 5.1. Then we have the graphs of y equals 7, this line right here, y equals 3, this line right here, and y equals 1, this line right here. So we're going to be able to use that picture to solve these equations. Notice that this equation right here, x squared minus 10x plus 28 equals 7, is the statement that this equation right here equals this one. So if two equations are equal, just like in chapter 4, where two equations are equal are going to be where those two equations intersect. So there are two places where those equations intersect, so there are two answers. X is going to equal 3, and X is going to equal 7. So those are the two answers for this one. Now, notice that this ordered pair right here would have been 7, 7, and this ordered pair would have been 3, 7. Why didn't I care about the whole ordered pair? Well, I didn't care about the whole ordered pair because this equation that I'm writing right here doesn't have y in it at all. It's only an x I'm solving for. And I already knew that the y was going to be 7 because that's what I was saying my other equation was. Okay, so we're just looking at the x values here and trying to find out when these two equations are equal. Let's look at the next one. I want to know when x squared minus 10x plus 8 is equal to 3. So that's when this curve intersects this line, when these two lines are equal to each other. So right there, that happens only once at the x value of 5. This is just a picture, a graphical way of showing what happens when you get two answers or when you get one answer. Two answers, the line hits it twice. One answer is because it only hits it once, right when it's turning around at the vertex. And lastly, same thing, when this equation equals 1, we can see that it does not happen. So the answer to that one is going to be no solution. And we haven't seen a factoring no solution yet, but no solution is going to be something that we weren't able to solve. So I'm not able to solve it. That's the reason, is because that line never touches the graph of that parabola. So our results, just a summary right here, our results from that example show that a quadratic equation in one variable has either two real numbered solutions, one real numbered solution, or no real numbered solutions. Those are the three possible things that can happen. And the last example, looking at a word problem here. We've got a number of football games, going to be called N, that must be played in a league with T teams if each team is to play every other team once. Okay, so we have this formula that's describing that situation. And if a team has 45 games scheduled, okay, so the number of games that must be played in a league with T teams, how many teams must belong to the league, assuming that each team plays each team once. Okay, so 45 games scheduled, that's the number of games. And we want this to be the case that we only play each team once, so we don't know how many teams we need to have. This is going to start off as 45 equals t squared minus t over 2. This is a quadratic equation, but it is not in standard form. First of all, I don't like having this fraction here, so I'm going to go ahead and multiply both sides of the equation by 2. Okay, so that's going to give us t squared minus t on this side, and it's going to give us 90 on this side. Now, it's almost perfect. I just want to get it equal to 0. It doesn't matter if the 0 is on the right-hand side or the left. So I'm going to subtract 90 from both sides so that I can get this equal to 0. So I've got t squared minus, I was subtracting the 90 off. So it's going to be 0 on this side equals t squared minus t minus 90. Now let's factor. Need to factor that negative 90. It's negative, so when you use one positive and one negative, the negative is going to be larger to add to a negative. So let's go with negative 10 and a positive 9 adds to a negative 1, which is perfect for that negative 1t. So 0 equals t minus 10 times t plus 9. Let's set each one of those equal to 0. I'm going to do it up here where I've got a little bit more space. So t minus 10 equals 0. If I add 10 to both sides, that's going to give me t equals 10. And if I have t minus plus 9 equals 0, if I subtract 9 from both sides, I'm going to get t equals negative 9. Now there can't be negative 9 teams, so the answer is 10 teams.